Thank you. Yeah, I've added John Pinniger's name to this talk because actually a lot of the slides are from him. Some of you may have seen them before, and also Beata will be talking towards the end about as well. Most of the things I'll be talking about are North Sea. I'll try and touch a little bit on wider Europe, particularly the UK shelf. I'll run through a few different case studies, various different labs. A lot of it's from CFAS though, I must admit. And then, Beata will be talking about more of the northern seas. So, a bit of a plug for some CFAS time series. Partly to say how great the data is, but actually a lot of it's available, freely available online, or if that's not available, you can ask us for it. So it's not just covering UK waters. It's what I'll be talking about is mainly North Sea, but we do have data for up in the Barents Sea and wider areas. So if you do, you think that some of this data could be useful, then do have a look either on the CFAS website or ask myself or John. But basically, we do have data dating back to the early 20th century, and CFAS in its various different names have been monitoring fish coming into UK ports, and where and when and how much the fishermen have been catching. And also, as well as the catches, we're also monitoring a lot of research vessels. So back in 1902, the Huxley, and ever since we've been monitoring fish populations. So here's some of the survey vessels, just to show you really the spread of data. Although actually that's clipped to the North Sea, as I say, it does go wider than that. But looking at all these different research vessels, which are shown there, there's a general change in the North Sea where warm water species with smaller maximum body sizes have increased in abundance as a sort of general trend. But also, as I say, there's this commercial catch data. So this is a chart which there's in each of these there's two numbers, the top being the catch and the bottom being the effort. And there were 37,000 of these statistical charts, and some poor soul has digitised all of this. And we now have a database of all of this data going back to 1913. And these are some of the commercial vessels going from sailing ships all the way to more modern commercial vessels. And then so now I'll talk a bit more about what it actually means for some of the species and what that data can tell us. So we tend to think of climate change as changing into to warmer waters, but back in the 20th century, a lot of the problems, some of the problems, particularly for sole, were cold winters. So so these three studies from 1929, 47 and 63 all look at a really cold winter years and the impact that has on sole mortality. And here's one example of those. This is photos from the winter of 62 and 63, where the bottom right photo is the Thames having frozen, and the others are the southern England, where the sea froze. So, and the temperature, only a couple of the winters actually on temperature record were colder than these winters. But basically, this study looked at the impact on sole. So this particular winter, dead sole were caught off the Dogger Bank during February and April. But in March, there were some really, really high catches of dead sole. And in fact, between 10 and 20% of the sole that were caught, 10 and 50% of the sole caught were actually dead. And this figure here shows the distribution of those dead fish in the North Sea. Highest mortalities were at the 2-degree isotherm, and the sole in this particular year were found to have completely avoided the shallow coastal areas. and there was a much higher density of fish than in the deeper water than you would find in a normal winter. And this study by Woodhead found that when the sea temperatures are low, it takes much longer for the sole to arrive back at the coast. In fact, in this year, it was delayed by up to four weeks. And we see, looking at this long time series, the sole have actually retreated further south and into shallower waters towards the English Channel in more recent years. So in the 1920s, you can see that the dark circles are the higher density of sole. And in the 1920s, 30s, 40s, you found them all along sort of from the English Channel all the way to Denmark. But you see, actually, throughout the century, they've retreated a lot more just into that shallow water over to the east coast. And then, so George Engelhard and colleagues looked at this shift and looked at where sole have traditionally migrated offshore to avoid the cold winters in these shallow areas, but actually they're able to stay in the shallow water all year round. So you can see from the figures there that throughout the century, so on the x-axis it goes from 1910 to 2010. So they've moved further north to the middle of the century and then headed further south, and then they also went gradually west, as I say, towards the east coast of England, and then they've gone gradually. They're able to go and stay in shallower waters all year round. Oh, there you go. Oh, and that's that cold winter where they went much deeper. So then moving on to plaice, which is a slightly different story. Plaice were constrained to the southeast of the North Sea for much of the 20th century, but they've actually shifted further northwest towards the Dogger Bank. So again, from the figures, you can see that sort of spread on the southern North Sea in the 1920s, 30s and 40s. But then they're moving further north in the 60s and 70s and actually move across the North Sea over towards Scotland and then the northeast, much more so in the 90s and the 20s. So this is the same paper by George Engelhard, where they found that latitude, temperature and depth were highly correlated in the North Sea, and you can see there how the shifts changed for the plaice. So they went much further north. They went gradually further east, but then shifted west, as I say, over to the Scottish coast, and then they've gradually gone deeper. And touching a little bit for plaice, many of you will have heard of the plaice box. So this is the orangey yellow area down there that was established in 1989 to reduce fishing on the nursery grounds. But surveys in that area, this study's from 2007, have shown that actually there were, at that time there were very, very few plaice left in that particular fish box, and so it has been much less effective. And John Pinniger will be talking a bit more about what that means for management tomorrow. But it's just one example of why it sort of matters a bit if you know where the fish are. And there's just sort of showing how the survey data shows they've been moving out of that area over the century. And moving on to turbot. So this is a slightly larger species than the sole or the plaice. And again, going through the century, it was formerly widely distributed across the North Sea, but actually since the 1960s, it's almost completely disappeared from the northeast. And it's much more dense down sort of the southern or the mid-North Sea. So what was called the turbot bank, they've almost completely disappeared from there. However, this study by Kirby, 2013, found that there was no evidence of climate effect, and this was more likely to do with fishing rather than temperature changes. And a couple of other flatfish species that aren't quite as widely known. they've both increased in abundance and moved to the north since the 1980s, and that coincides with a series of mild winters. But following a very cold winter in '96, the abundance decreased and they went further south. And this recent shift in temperature affected the adult conditions, and so they're in areas where they hadn't been before. And you can see there that on the right-hand figure, the black line shows the relative abundance and how they've increased. And then on the left-hand side, the sea surface temperature and the spawning stock biomass have also increased in that time. And you mentioned phenology earlier. I've just got a sneaky slide in on phenology. But again, using sort of similar data, how we can look at that. This is actually data that's come from market sampling in England and the Netherlands, which showed that the date of peak spawning for sole, which was estimated for 7 different stocks. So they're the different stocks in the figure on the left. And then on the right, you've got the sea surface temperature, how that's changed from 1970 to 2010 for all of those different stocks there. So if I move on, this market sampling included only female fish, and they did a 5-stage maturity classification. And they calculated for each week of the year the proportion of spawning females. So that allowed them to look at the mean spawning week, which is what these figures show. So on the y-axis, you've got the mean spawning week from 0 to 40 there. And then again, the years are from 1970 to 2010. And 4 of these 7 stocks showed a significant long-term trend, with earlier spawning at a rate of 1.5 weeks per decade. And the sea surface temperature, obviously during winter, affected the date of peak spawning. And this is unpublished data, so please don't tweet it if you're thinking about it. But this is looking at the place service survey data. I'll just put all of those on. So we can walk through the figure here. So we're starting at 1902, going through to 33, over here 34 to 63. This is the total length of the place, with the length frequency distribution on the y-axis for each of those. So starting at the beginning of the 20th century, there were many large plays present, and that's when intensive trawling began. So the numbers dropped substantially before the First World War, and there were, by the 20s and 30s, there was quite a lack of large place because of the overfishing. But in the Second World War, fishing stopped and place recovered so that you had larger and older fish by the time the Second World War ended. But then fishing started again, and so large fish became scarcer again in the 1950s. And you had large place in the 60s and 70s, and the hypothesis is that's related to eutrophication. And then in the 1980s, this is off the figure here, but in the 1980s, the population has again moved towards smaller sizes, which may be to do with climate change, it may be to do with fishing, and also eutrophication. So again, showing the interaction between all these different pressures and how that can affect these individuals. Going to one of the more important species for the UK plate, looking at cod. So this is IC's stock assessment data, and according to the assessment 2016, populations were heavily overfished in the early to mid 2000s. However, fishing was then significantly reduced to try and control the overfishing, and stock biomass increased to a more sustainable level. It was expected then that the recovery would happen, but it's actually been really quite slow. So I should point out these figures, sorry. So we've got the catch rates here that were really, really high, but actually decreased a lot in the last sort of decade. fishing pressure high and again decreased, but the spawning stock biomass has increased slightly, but actually recruitment's been really quite low compared with what it was earlier in the last century. So it's a thought that this this poor recruitment is because of the warm conditions that there have been more recently, which don't favour cod reproduction. So this just shows that it's not just climate and it's not just fishing; it's the interaction of the two that affects these stocks. Oh, and just a note, if you do eat cod while you're here in Scotland, the chances are it may not be have been caught here. So sea bass, and it's often sort of one of the poster child really of marine climate change in the UK. And there's evidence that the populations did expand in the early 2000s. So again, the landings increased here. That's 2005, shaking it. 2010 with really high landings, high fishing mortality, but the spawning stock biomass plummeted really, and low recruitment at the end of this last decade. And in recent years, the fishing mortality has been really unsustainable because the recruitment success has just been low. And they think that this is to do with the fewer cooler winters. So although in general we think the seas are being warmer, but actually if a cooler winter is required for the recruitment. And then North Atlantic mackerel, which I think somebody mentioned already this morning. In 2006, it was first observed in really large amounts east of Iceland, and particularly in the Norwegian herring fishery. And then that led to Iceland and the Faroes claiming a large quota and landing a lot of those fish. And the mackerel distribution changes have been linked to various things, including warmer seas, also food availability. Again, showing the sort of the interaction. It's not just one thing. So, if we think about food availability, are they chasing the food? What does it mean if a fish changes its distribution? What can it be eating? So again, another database that CFAS has been entering logbooks for. It's called the DAPSTOM database, and you can look it up and download any data you like from it. I think it includes more records than that by now because we're constantly digitising it. But it's searchable. It's quite easy to navigate. And it's been possible to compare the stomach contents of fish. We've also got a lot of the length data as well for those fish. This in particular that I'll talk about was looking at the beginning of the 20th century, the middle, and then the beginning of the 21st century. And this was comparing place and DAB. So again, if I point out some things. So we've got here the 1900s, 1950s, 2000s. It's the same for both species. This is the proportion from 0 to 100%, the proportion of prey items found in each stomach. The red colour here is molluscs. So you can see that for both species, the proportion of molluscs eaten by the fish has decreased really quite substantially over in the last century. This bright green here is polychaetes, so this has increased a lot in the place, less so here. The yellow is sand eels, which has increased for both, and then there's various others, unidentified fish are cropping up, and various, what have we got here? They're crustaceans, and then the crabs and hermits are much more important at the beginning of both centuries, less so in the middle there. So again, is it just climate? Probably not. Probably due to a lot of beam trawling, removing some of those slow-growing molluscs. But yeah, there's various hypotheses. Could be influence of climate change. Could be both. And this is just to mention some broader studies rather than the species-specific stuff. So Steve Simpson in 2011 looked at this figures from his paper, looked at the sort of abundance responses to temperature. So I think they looked at the 1980s to early 2000s, I think, and how the abundance of all these different species were affected by temperature. So here, this is the abundance response. So the red ones showed an increased abundance with increasing temperature, whereas the blue showed a decreasing abundance with an increase in temperature. And these species towards the top are more northern species. These are more southern species. And most of those southern species, oddly enough, show the increased abundance with temperature. So that was sort of an overall, rather than looking at species specific, they looked at the overall changes. Another study, which is, I think both of these have been mentioned this morning, where Perry found that generally distribution shifts were between 48 and 400 kilometres, but then Dulvey looked at the deepening, as it's already been mentioned this morning. And then, if you'll allow me an invertebrate, we're talking about fish, but Jeroen van der Kooi recently looked at squid catches from the trawl data that we have at CFAS, and they looked at 1980 to 2014, and these are late summer survey catches. Fairly within this time, the summer squid fisheries have expanded rapidly in Scotland in particular, and actually it's been a means for some of the fishers to maintain their income when they've been restricted with catching other species, other more traditional species. And this is a screenshot from George Engelhard's poster on the same paper. So in the last 3 decades, as I say, the fisheries have grown, and in some cases the Scottish squid landings are actually comparable to finfish landings in certain months and certain years, and the figure on the right shows the rise in these squid landings from 1980 to 2010. They show the peaks and troughs there, but gradual, an overall increase. And then there's some quotations there, if you can read them, which were in the Fishing News in 2016, whether or not fishers were fishing squid because they had to, there was nothing else. But this paper wanted to answer 2 questions. So, yes, they were catching more squid. Was that because there were more squid, or was it because that's what they were targeting? And then this figure here on the left shows that actually, the occurrence from the survey data, the occurrence was increasing with time. And then on the right-hand side, the squid are actually expanding their range as well. So the distribution across the North Sea, it was squid were only found in 20% of survey stations in the 20s, but in the 80s. But in 2014, they were found in 60% of surveys. Did that move? Yes. Yeah, so the second question they wanted to know was what was the role of climate change or temperature in this? Again, talking about the North Sea being one of these hotspots. So that's the sea surface temperature change since 1980 on the left-hand side. And then this is the squid abundance. So there's annual sea surface temperature on the x-axis there, and the log catch rate. So they found that sea surface temperature, but also the AMO and the inflow were very tightly associated with these squid dynamics. Okay, so I'll hand over some different examples.
Yeah, thank you, Bjarne. So I'll just like to get a little bit back to the mackerel first. Now I guess Steve Mackinson knows more than me about this. But if you look at these maps, they go to 2016, and there has, as Bjarne was showing also, there's been a big westwards expansion of the mackerel distribution area. It's been much more westwards than northwards, and we don't quite know whether they prefer going that way. For the sake of the temperature, they could probably go a bit more north than they have done also. We see them more northerly along the Norwegian coast, but they have not gone into the Barents Sea up in north, as they probably, I guess at least the temperature should allow them to do so. Now what's happened after these slides, I think 2016-17 was about like 16, but in 2018, maybe because the stock is decreasing, the distribution did not go as far west as in 17. So, well, we'll see if that is a trend or not. But it was a marked difference between 2018 and 2017, which I didn't have that map around. So that's and I mean this is a really big stock, and here also, without taking it spawns mostly west of Ireland, which is almost not on the map, and these changes have caused a lot of discussion about zonal attachment and sharing of quotas and stuff, which I'm not going further into, but that's been a really big issue because they went into waters where they had not been before. Icelandic fishermen almost had to be told, however, they were not used to seeing mackerel at all, as far as I know. Well, if we go 80 years back, then maybe, but that was quite not a very well-known species in Icelandic waters. Yeah, and then to the cod. Northeast cod. First, I should say that it's deep out here. It's also deep in the far north, and for the temperature, there is of course a gradient to the north, but there's also a gradient to the east, especially in winter. It tends to freeze. The cod spawn mainly down here, and here we have the border between Norway and Russia, and all the dots on the map are above the Arctic Circle, so we're pretty far north. So this figure is essentially, this is cod above 49 centimeters. This figure essentially indicates that we were lagging behind in extending the survey area, because there may well have been cod up here in February in 2008, but we didn't go there. I did not have so comparable maps going back into the 90s and 80s. The survey series go that far back, but then we were limiting ourselves to a survey area like this, and that seemed to be enough. So we increased the survey area. This is our main survey in '94, and then again in 2014. So, but if we look at the autumn survey in autumn, we see a big change in the distribution area for cod. So essentially there was a big shelf area that it could move into. Of course, in this period we had a large increase in stock size, partly because of the introduction of a harvest control rule and lowering the fishing mortalities and things like that. But also there was a lot of shallow waters that the cod could move into, and that's not the case everywhere. So it's shallow all the way up here, and here you go into the deep polar ocean. So this was a big change, but as I said earlier today, there has not been much change in the spawning area. And also we see that the biggest cod is found farthest to the north, and of course we had a decrease increase in stock size. We get more big fish, and they can more easily swim farther north also. So that is part of the pattern. And I mean, you also see that the cod have been covering bigger areas in the southeast and the east, especially along this long island there, which is which is not New Zealand, it's Novaya Zemlya. And cod seem to we find little cod when the temperatures goes below 0 degrees. That's kind of a rule of thumb. We do find cod below 0, but not all that much. And then to the what can I say? The little sister, the haddock. This is same kind of map, and I forgot to say in hatched area. That's where ice cover. And we see also here that we were lagging a bit behind in the. It's the same survey, bottom trawl, and also here there's a big increase on the stock. But both on the haddock, they are now past the peak in stock size and on the way down. And then there was also for this one there was a big expansion in the area of summer. Now haddock they tend not to want to go below 2 degrees. So as a rule of thumb. So there's a quite big difference in the cod and haddock distribution in the northeast in particular. But we see that the haddock has now moved almost all the way east to what we call the Kara Gate, which is here. This is the cold Kara Sea. So this is just an let's see. Yeah, I should also say that of course there's been written quite a lot of papers on changes in distribution in this area, and one of them is what I call the borealization paper, which is Maria Fossheim and colleagues. They were looking at how much the various fish communities, the boreal, Arctic, whatever, in this area were moving northwards, and the rates were something like between 100 and 150 kilometers per decade, which is a bit. So and if you are the cold water guys and girls who are occupying the far northern area, you could risk being pushed or outcompeted, eaten, whatever, by the more as it gets warmer, and some could, if you get out here into the deep Arctic Ocean, you're in trouble. I should also say that the distribution of quotas in this area between Norway and Russia was fixed in the 70s when the 200-mile zones were established, and they have so far not been up for discussion, fortunately. So it's a very different setting between here and the mackerel, where there's a constant haggling for quotas. Now the cod has been moving probably more into Russian waters. On the other hand, the Russians or the Soviets rather, that's so far back, they got a good deal when this split was established. So we're so this isn't really up for discussion, fortunately. Yeah, well, that goes for both Brian and me. Yeah.
Okay, great. Thanks, Briony and Bjarte. So, questions? Give it a few minutes for a few quick comments or question generators.
Thank you. I was surprised, not surprised so much, but the notion that when we think about temperature change and whether the most profound effect is in the summer or the winter is kind of important, because like in our area of the world, our surveys occur generally in the summer, and we don't really know per se, other than say temperature moorings, what the temperatures are like. I mean, we know what they're like, but we don't exactly know the temperature the fish are experiencing in the winter time. So that's sort of a dearth in our knowledge. But relative to what you were talking about, I guess you were saying that the big effect was the winter temperature, and I'm curious if there's any relationship to that in the Arctic high that has historically been weakening, and that in the winter, although the summer might be warmer, sort of in a trend, actually the winter may not be as warm. It might be staying cooler in deeper water, and I just thought that maybe you could comment whether you think that that's an important thing that needs to be considered when we're looking at, you know, how animals respond to climate effects.
Yeah, thanks for the question. Yeah, absolutely. I think it's one of those where we don't necessarily look at all these, you know, when we're looking at the correlations, don't necessarily look at all the different options. So not just the summer or the winter temperatures, or that was the AMO index, I think there, and all these different things. And sometimes, even if we've got a nice, we do have the temperature throughout the year sometimes, but if that surface is at bottom, you know, it all has an effect, doesn't it? Did you have anything you wanted to
No.
I can comment on the comment with respect to, just related to this question. In the Icelandic cod, there's in a sense, probably two ecotypes of populations with respect to how they behave towards temperature, actually towards depth, or even towards distances migrated. And one of these seafarers actually never observed a summer. There's high temperatures actually spring when they come onto the shallow water to spawn, and then they go to the deeper waters along the coastal current fronts, in East Greenland and also in East Iceland, where the temperature is basically zero. That's in summertime. So these kind of things can be complicated. And also, well, as I mentioned, there are two ecotypes. I mean, there's then another type that seems to be somehow related to zooxanthellae genetics that stays basically in the summer, in the shallow waters and experiences the summer. So yes, when you go to these areas where you have high temperature gradient, like in the these fronts which we have in Icelandic waters, and I guess also in Canadian waters, we are not sort of, we probably have a species, a restriction just by these temperatures, but also the species that are occupying this space currently, their behavior might be totally different from what the average temperature might be saying in the surface.
I think it's worth saying actually, there's starting to be a lot more fish tagging data coming through as tags go out and fish get caught. Certainly quite a lot for Europe and elsewhere, where they have temperature sensors within the fish. So you would be able to see some of that. Obviously, it's really small amounts of data that we have.
Yeah, I think it also differs a lot between stocks, how long spawning migration they make, and I guess of course, and that would affect this picture also. But thanks a lot to Einar for pointing out that cod and some other stocks are actually in probably in colder waters in summer than in winter. So, which is connected with the migration, of course.
Bjart, I have a question for you related. Brian talk, took advantage of long time series from industry data. Your perception, is what you presented today was based on survey data. So I'm just wondering, do you know of any data resources in the Barents Sea that would be very long time scales of distribution of fishing?
Well, we have this, for instance, we have the first thing that comes to my mind is the Sundby and Nakken paper. Well, there is a paper describing quite well how the spawning areas have changed over a long time based on landings or on a small scale. I mean, that doesn't tell for the rest of the year, but that's a kind of a firm thing. Then before our service started in the 80s, we have been, there has been diggings into the literature trying to see where were fishing going on in the last previous warm period, which was in the 30s and things like that. But this with actual hard data and time series is a more difficult thing to.
I guess you'd also be looking at the Russians, for for
Oh,
data
yes.
in this regard, because they would
They actually were much earlier out than us on having survey series. They started just
Yeah.
after World War II, and they did actually some stomach sampling in the 30s. So there's a lot of data on that side. They are not always as accessible as now, and you both know. But I mean, I tend to remember then that the longest code in our waters officially recorded was 1 meter and 69 caught by a Russian vessel in 1940, and that was 24 years old. So that's for the infinity discussion. But I think it would be hard to find so long time series as they have at CFAS. On oceanography, yes, but not on. That would be not anything that would be easily used for quantifying how much fish there was.
Interesting.
Again, I think CFAS might have some data from the Barents Sea, from commercial fishery where they took place. They certainly have it from Iceland, and we've been digitizing those. Just go back to the 30s. So, and this would apply probably also to ferries in Greenland waters.
Yeah.
Commercial catch and effort by statistical squares. Whatever they're worth for this project, that's another thing.
Yeah. There is some. I mean, it is publicly available actually, but there is some commercial from data from UK vessels, I think in the 1930s. But the UK did do surveys, research surveys in the Barents Sea from the 40s, I think. Might be the 30s, but definitely the 40s. But you're aware of that. But it wasn't. The survey vessel actually acted like a commercial vessel, so it chased the large catches. So it's not a nice grid, and you can't say that there's these changes in the population, sadly, because they did. If they found a large chunk of cod, they stayed there rather than moving on. So that there isn't this. You don't get the spatial pattern, sadly. But there is some data to use with caution.
There's an interesting parallel here, because we saw Gretchen's presentation, how she was trying to piece together data from all these diverse range of sources that were, for us who are used to having surveys at our fingertips. But in essence, surveys, you're always trying to patch them together, and they're imperfect as well. So perfection certainly doesn't exist when it comes to trying to characterize changing distributions over time, whether it's surveys or non-survey information.
I was just going to make one more comment. I probably don't need this, but all right. It has to do. I mean, I'm sure we're going to have a conversation about indices of temperature, how synoptic they are with regard to the populations we want to study. Bottom trawls are a good example where we have temperature data on the net mensuration equipment, so we have relatively good temperature spatially. Of course, that's only during the time that the survey is occurring, but when we think about the space that fish occupy in terms of their temperature availability, we also have to think about it in a time frame as well, so that if we're looking at an annually resolved temperature growth or distribution relationship, it may be a couple of years before an animal actually experiences the impact of that temperature, particularly if it's a demersal animal. Like we've recently seen with Pacific cod in the marine heat wave in the North Pacific. It took a couple of years before the heat wave actually broke any stratification, and that it reached the bottom temperatures where the cod were normally located. So it would be a several year lag before that animal may have become impacted in terms of growth. So I just sort of highlight that notion that we've got a pretty complex picture that we're trying to disentangle, and that there's all kinds of considerations that we need to be thinking about.
Okay, yes. Want to comment?
Yeah. That reminds me of a very relevant point, and that is does there seem to be, or are there sort of standards or some sort of agreement on what temperature trends to choose? Because it seems to me that people can pick and choose, and you know, the sheer number of them, bottom surface, various locations. When we asked the icy oceanographers, for example, you know, what should we use for the North Sea as a temperature trend? Well, there are several. You choose, and the choice, you know, you can pick the one that fits your data better. And then if you add a lag choice as well, suddenly you're into permutations whereby, you know, the chance of you getting a significant result becomes significant. You know, and I just wonder what sort of standards there are for choosing these things or averaging them to come to an agreed set of, you know, particular temperatures that you can use robustly.
Isn't that your area?
Where is it?
Yeah, so one of the papers we might talk about on Thursday is by Tim Miller. His work with the Georges Bank data set, you know, off the northeast U.S. And I thought it was really kind of clever because he's modeling, you know, fish length at age and also fish weight at age, but at the same time he's modeling temperature in Georges Bank as kind of a stochastic process. You know, so he's considering that you know, he's using anomalies from an overall mean, so he kind of said that's sort of a process, and those anomalies are maybe considered sort of process errors, you know, or deviations from what a model will predict. But then there's also you might consider observation errors too. I mean, the observations we have for temperature may not exactly represent exactly the truth in all locations. So I thought it was kind of a clever way of doing it. But you know, he's got a really detailed data set. You know, so you know, they have temperatures, you know, at various locations in the surveys going back to the 60s. But then he's got, you know, so that kind of gives you, you know, points at the spring and the fall surveys. But then he's got about a decade of basically monthly temperatures, and that's what he uses to create like an annual cycle of temperatures, and that's what he used to sort of, you know, take out the seasonal variability. So he's